We're going to talk about variation, and we can say that a quantity varies directly, inversely, or jointly. We have three types of variation. I'll give you an example so you understand each. For example, I can say y varies directly as x. So I'm talking about the variable y varies directly as x. What that means is that as y gets larger, x gets larger. And when we see that wording, y varies directly as x, we can think of it as being the formula y equals k times x. And k is known as the proportionality of variation. So this is the constant of proportionality, or the constant of variation. To continue this problem, I might say y varies directly as x when y is 65, when x is 5, and then I might say find y when x is 12. You will notice that I have a y value and an x value. If I use this in my direct variation equation, it's going to be enough information that I can find the k value. I'm using the formula y equals k times x. I now substitute y is 65, k times when x is 5. So I get k times 5, or 5k. This gives me enough information that I can find for this particular variation problem what that constant of variation is. To solve for k, I divide both sides by 5, and I get k is 13. So for this particular variation situation, I know that from this y will be, now I know what k is, I'll be able to plug that in to the situation. Therefore, in this particular problem, y equals 13 times x. That's the equation that gives us the information for this specifics. Now I'm asked to find the y value when x is 12. So all I need to do is let x equal 12, and that'll give me the y value for that. So what I do is I let x be 12, and I get y is, so we're letting x be 12, 13 times x times 12, which is 156. So for this particular variation situation, when y was 16, y was 65 when x was 5, we got that when x is 12, y would be 156. We're going to go on and look at inverse variation. So for example, if I say y varies inversely as x, the inversely, what that's expressing is y gets larger, x gets smaller. And the way we accomplish that is we let y be a number over x. The variation equation becomes y equals k divided by x. Again, k is what's called the variation constant. Just like I did for direct variation, I will say if y varies inversely as x, when x is 5, y is 45, find y when x is 13. So what we're going to do here is we're going to find k. We're going to find the k value. And to do that, we're going to substitute. We know that y is 45, and that's k divided by 5. I just cross multiply. K equals 45 times 5, which is 225. Now that I have the K value, I am just going to replace it in the inverse variation formula. For this situation, I now know that y is 225 divided by x. That's the formula that goes with this inverse variation situation. Now I have to find y when x is 13, so I'm going to let x be 13, and I get y is 225 divided by 13, which is 17.3 approximately. So that would be the y value for that situation. Now we'll look at joint variation. So for example, I might say y varies jointly as x and z, those two variables. This in a way is like a joint, this joint one is like a direct, only its y is a constant times x times z. So you jointly multiply xz times the k. So a specific example might be, I might tell you y varies jointly as x and z, and y is 25 when x is 2 and z is 5. Then I ask you to find y when x is 8 and z is 12. That's that particular situation. Our first step is to find k, so we're going to use these values in the joint variation formula. Substituting in, letting y be 25, we get 25 is k times x times z. X is 2, z is 5. We now have that 10k is 25. Working this through, we get k is 25 divided by 10, and I like to reduce these, so dividing top and bottom by 5. K is 5/2. Now I put in the actual new equation with this k value. Y is 5/2 xz, and now we're ready to substitute x being 8 and z being 12. We let x be 8, z be 12, and we get y is 5/2 times 8 times 12, which is 5/2 times 96. But 2 goes into 96 48 times, so we get 5 times 48, which is 240.